Hello everyone and welcome back to session 3 of C programming. As usual, we'll start by recapping what it is we learned in session 2. In the previous session, we discussed variables and constants, and we also distinguished between what is a variable and what is a constant. We looked at the various data types used in the C programming language, and we made use of them in our C programs, and we wound up the session by looking at some sample variable declarations. Let's start our session today by looking at the session objectives. By the end of this session, you'll be in a position 1 to explain the assignment operator, 2 understand arithmetic expressions, 3 explain relational and logical operators, 4 understand bitwise logical operators and expressions. You'll also be in a position to explain what is a cast and how to do it, and we'll wind up the session by understanding the precedence of operators. Let's get started by looking at what exactly is this thing we're calling an expression. Now, in the C programming language, an expression is simply a combination of operators and operands. And we can see the times and the plus are what you're calling the operators. Then 2, y, and 5 are what we are calling the operands. Now we can see what they are, but let's define exactly what these operators and operands are. An operator in the C programming language is a symbol that modifies or manipulates a variable or a value. And some examples of operators include the plus, times, equal, plus plus, modulus, or the greater than sign. We can also look at what exactly an operand is. The operand is the data which is modified or manipulated by the operator, and it can either be literal, e.g. 5, or a variable, for example, first number. Having understood what is an operator and an operand, let's look at the assignment operator in the C programming language. The assignment operator, that is the equals, can be used with any valid C expression. And we can see the general form of the assignment operator. We have a variable name, then you assign the value on its right side. So this is the left value. We have the assignment operator, and we have the right value. What usually happens is that we usually do some calculation on this side, or we can have a literal value, and we assign it to whatever is on the left side. We can use the example we learned in high school. For example, how do we calculate the area of a rectangle? The area of a rectangle is given by length times width. Now we have this calculation here. A is equals to length times width. Usually what happens is that we would first of all multiply the length and the width, and the resulting value is what will result as the area of that particular rectangle. The C programming language allows us to perform multiple assignments in a single line, and let's see how we go about it. Now, many variables can be assigned the same value in a single statement, and we can see what is happening here. We have A, B, and C, all these are variable, and all of them are assigned the value 10. Now, what usually happens for the assignment operator, that is the equals, the associativity is from left to right. What is this thing I'm calling associativity? Associativity means that we evaluate it starting from the left side, starting from the right side, moving towards the left. This means that this assignment is going to be take 10, assign it to C, take the value in C which is 10, assign it to B, and do the same for A. However, you are not allowed to do this in the C programming language. Let's see how you would actually do this if you were to write a C program. You will start by declaring 3 integer variables, that is A, B, and C, and then you can write it exactly the way it is in your slides. Alternatively, you can also do something like this, and it's perfectly valid. It still works the same way. You declare A as an integer, assign it to the value 10. The same for B, assign it 10. Then you do finally the same for C and assign it the value 10. And remember, we said that every statement in the C programming language must be terminated with a semicolon or a colon in English US. Let's move on and look at the various operators we have in the C programming language. The C programming language provides us with 4 types of operators. We have the arithmetic, logical, relational, and bitwise operators. Let's quickly define these operators. An arithmetic operator is one which performs the traditional mathematical operations like addition, multiplications on variables, and literals. Examples of these include the following. We have those ones which are classified as multiplicative. Multiplicative is the plus, divide, and the modulus. Then additive, we have the plus and minus. Now, I'm quite sure for some of us, we expect this to be the percentage symbol, but I'm calling it modulus or modulo. What exactly is this modulus or modulo? We can look at the example and we can see that the remainder will be assigned by first num modulus the second number. Let's look at a practical example where this would be something like 8 modulus 5. How do we go about this? For modulo or modulus arithmetic, we just do the normal division without any decimal places. So this will be 8, okay? Then you divide by 5. Now this goes here one time, okay? And we can subtract this. The remainder obviously is 3. Remember, we've said we're not dealing with any decimal places. Then we would write 1, then remainder 3. Okay? Now, we are not interested in this part, okay? We're interested in the remainder or the modulo, okay? So we take this, and this is the answer of 8 modulus 5, okay? Is equals to 3. I hope now that makes that clear. Let's move on. Used in arithmetic expressions. So mathematical expressions can be expressed in C using the arithmetic operators which we've looked at. Examples is plus plus I modulus 7. Okay, we'll see what this does, don't worry. 5 plus C is equals to 3 plus 8. A times B plus C divided by D, then close the brackets or parentheses, times 22. So these are the various arithmetic operators that you do in the C programming language. We will see so many examples as we write the actual program. After understanding the arithmetic operators, we move to the relational and logical operators. The relational operators are used to test the relationship between either two variables or between a variable and a constant. And this is what we learned in high school arithmetic. We have the greater than symbol. This one simply tests whether one value is greater than the other one. And something before I forget, once we do this, once we compare or test the two relationships, the relationship between the two variables or constants, the result is always true or false. We call that a Boolean or Boolean in programming. The next one is greater than or equal to, whether one number is greater than or equal to the other one. Next one is less than. We have less than or equal to. When we want to test for equality, we use two equals symbols. This is what is used to test for equality, since the single equal is the assignment operator. Okay. Then when we precede the equal sign with the exclamation mark, this is called a bang in programming. Then this means not equal to. One number not equal or one constant not equal to another one. Okay. After that, we have the logical operators. Logical operators are symbols that are used to combine or negate operations containing relational operators. And let's look at the operators and what they mean. When you have two ampersands, this means and. You remember the previous example in session 1 when we wanted to find out whether somebody can be classified as an MVS or not. Then when we have two pipe symbols, that is the double pipe, this means OR, and it means whether this part A or part B is false or true. And something to note is that even this also evaluates to either a true or false value. The last one, the exclamation mark, simply means not. And we have an example here. If A is greater than 10 and A is greater than 20, then we do some calculation. Expressions that use logical operators return 0 for false and 1 for true. Let's look at an actual example in Notepad. Assuming you've been given this scenario, you are supposed to assign a student a grade B when their score is either 60 all the way to 69. This is the way you would actually write the code. We can say when the score is greater than or equal to 60 and the score is less than 70, or if you wish, you can still do something like you can change the logic by, and then you make this 69. It does the same thing. Then we assign the student a grade B. But I prefer what it was previously. It's at least a little bit less typing. Okay, but feel free to write it the way that suits you, as long as the logic is correct. This is how we combine these two, and when this evaluates to true, then we assign that particular student a grade of B in their exam. After looking at the logical operators, let's look at the bitwise logical operators. A bitwise logical operator will process the data after you convert the number to its binary equivalent. What is this thing we are calling a binary equivalent? Now, when working with computers, we have various numbering systems. We have base 10, that is the way we count. From 0 to 9, we call that decimal because we have 10 numbers. We are saying that decimal, that is base 10, is numbers ranging from 0 to 9. This is what we usually count or use. Then we have hexadecimal. This is base 16. Hex is 6, decimal is 10. 6 plus 10 gives you 16. That is the numbers from 0 to 9. Then once you get to 10, we don't write 10, we write A all the way to F. F is 15. Then we have the octo. Octo are numbers which range from 0 to 7, that is to base 8. Then we have binary. Binary is base 2. These are the numbers 0 and 1. And this is the computer's native language. What we're saying here is that once you want to do the bitwise logical manipulation, you have to convert numbers, the number from the decimal format, that is what we normally use, to the binary format. Then you can manipulate the ones and zeros. Let's see how we go about it. We have the bitwise logical AND. Kindly note that this is a single ampersand as compared to the previous slide where we had the double ampersand. This one will first of all convert the two numbers to ones and zeros. It will return 1 when both the operands are 1. That is when you have a 1 and a 1. All the other times, if you have 0 and 1, will evaluate to 0. Then 1 and 0 will also evaluate to 0. Then 0 and 0 is automatically 0. Then when we have 1 and 1, that's the only time we get a 1. The next one is the bitwise logical OR, and this one will return 1 if bits of either of the operand are 1. When you have 0 or 0, then that evaluates to a 0. 0 or 1, that evaluates to a 1. 1 or 0 evaluates to a 1, and 1 or 1 evaluates to a 1. Now, I know I'm talking too much, but I'll show you this in a Microsoft Excel worksheet so that it all makes sense. Not basically reverses the bits of its operands, that is from 0 to 1 and 1 to 0. And the last one is the exclusive OR, and this one return 1. It will return 1 if either of the bits in an operand is 1, but not when both of them are 1s. That is the case it is excluding. So in order to understand this, let's switch over to Microsoft Excel so that I can illustrate. Start with the bitwise and you can see the operator is given here. Now we have 0, 1 and 0, 1 on the columns and on the rows. When you have 0 and 0, this evaluates to 0. When you have a 0 and a 1, then this evaluates also to a 0. When you have a 1 and a 0, this evaluates to 0. And it is only when we have 1 and 1 that this evaluates to a 1. Okay? Let's look at the bitwise OR. For the bitwise OR, when you have 0 or 0, this evaluates to 0. But we can see for all the others, when we have 0 or 1, this evaluates to 1. 1 or 0, this evaluates to 1. And finally, 1 or 1 evaluates to 1. Then the last one is the exclusive OR. We can see for the bitwise XOR or exclusive OR, when you have a 0, XOR 0, this evaluates to 0. 0 XOR 1, this evaluates to a 1. Then 1 XOR 0, this evaluates to a 1. And finally, when you have 1 XOR 1, this evaluates to a 0. This is now what you're calling, it's excluding 1 XOR 1. Let's compare the two, that is the XOR and the OR, so that we can see the distinction between the two. The main distinction between the two is the last part, whereby 1 or 1 evaluates to a 1, but 1 XOR 1 evaluates to a 0. So it means it excludes this particular part. Let's look at some examples of some bitwise logical operators. To do this calculation, we are going to use the calculator in our computer. I'm actually using Windows 10, as at the time of this recording, you may have a newer version of Windows, but the procedure to open the calculator usually stays the same in various versions of Windows. Now the steps are given here to open your calculator. To open the calculator in Windows operating system, you click on the Start menu, then in the search box or in Cortana in Windows 10, you type in calc, then tap on enter on your keyboard, and this will open for you the Windows calculator. Now, once the calculator opens, you can switch to the programmer calculator by clicking on the menu, then you select programmer, and this opens for you the programmer calculator. And from here, you can see we have the various numbering systems. We have hexadecimal, decimal, octo, and binary. Now we want to do 10 and 15, so we click on 10, click on bitwise, then click AND, then 15, then click equals, and you can see, and this evaluates to 1010, and the decimal equivalent of this is 10. Okay, you can see the answer here. The next one is 10 or 15. You can clear 10 or 15 equal 15. So the answer is 4 ones, and this basically equates to 15. The next one is 10 XOR 15. Clear 10 XOR 15. Then this gives you 0101, and this equates to 5 base 10, as you can see here. Okay, if you're using Windows 7, you can click on the view menu, then from the view menu you select programmer. That will give you the same calculator that we are using here. Now then the last one, not 10, clear, then 10 bitwise, not, and you can see the answer here. We can move on. Type conversion in programming refers to changing or modifying one data type to another. For example, an integer to long or a float to a double. And we have two types of type conversion. We have the automatic type conversion done automatically for you by the programming language. And we have the other one where you have to force, which is called casting. Let's start by looking at the automatic type conversion. The rules used in automatic type conversions in an expression are given below. So the first one is char and short are converted to int and float is converted to double. Notice what is happening is that the smaller data types are being converted to the larger data types. B, if either operand is double, the other is converted to double and the result is double. Then C, if either operand is long, the other is converted to long and the result is long. Now, this is an image I can't change. It's supposed to be long. If the operand is unsigned and the other is also converted to unsigned and the result is also unsigned, else all that are left are the operands of type int and the result is int. Let's look at a quick example here. We have ch of type char, I which is an integer, f which is a float, d which is a double, and the result will be given by, in brackets or parentheses, ch divided by I plus f times d in parentheses or brackets minus f plus I in brackets. We start from the left side moving to the right. Now you'll understand why I'm actually following the precedence rules. We'll see what the precedence rules are. ch is of type char, I is an integer. So since these are smaller, they'll be converted to the larger data type. Okay, so the result of this will be an integer. Then this f is a float and d is a double. B comes into operation. If either operand is double, the other is converted into double and the result is double. So the result of this is a double. Then this one is f and I. F is larger or float is larger than an int. Therefore, the int will be converted to float and the result will be a float. Plus and minus, they have the same precedence. So we start from the left. Remember, associativity. This will be an integer plus a double. Then B comes into operation. If either operand is double, the other is converted to double and the result is double. This evaluates to a double. Then we have a double minus a float. B comes into operation again and the result of this calculation is a double. Let's look at the other type of conversion which we can do. This is called a cast. An expression can be forced to be of a certain type by using a cast, and the general syntax we said is the general form of something. We start by using the typecast operation and then you convert the data. This data is to be converted or to be cast into this type, where the type is any valid C data type. Float, integer, double, whatever you want to cast to. Now let's look at an example here very quickly to help us understand. We have two floats, that is x and f. F is assigned the value of pi. We take the value of f, cast it into an integer, and the resulting integer will be assigned into x. This is what happens. The integer value returned by int f is converted back to floating point when it crosses the assignment operator. The value of f itself is not changed. It remains as 3.14f. However, the value of x will be 3.000 because what usually happens is that we have said integers, they don't have any floating point value. That is, they are numbers without decimal places. Anything after this is usually dropped. It does not matter whether this is 3.9999, it will just drop everything after the decimal place and we are left with the numeral 3 or the numeric value 3. It's very, very important for us to understand this, for if we don't, we might come up with a program that is going to give us erroneous output. Let me illustrate. Assuming we have this scenario, we have the price of a given product, it's 100, and you're offered a 20% discount, then the selling price will be calculated this way. It will be the price minus the discount. So this is 100 times 20%, and this gives you 20. 100 minus 20 is 80. Now, if you were to do this in an actual program, let's see what we would get as the results. We have an actual C program here. It's written in code blocks. What is happening is we are taking the amount, then we start by calculating the discount, that is 20 divided by 100. And once we get the result here, we multiply it times 100, and then we subtract the result of this from 100. This is supposed to give us 80. But what happens when we run the program? It actually gives us an erroneous value. You can see it's telling us that the selling price is 100. What exactly is happening here? This is an integer value, and this is an integer value. If you divide 20 by 100, the answer is 0.2. But now, since we are doing integer division, remember we have said that everything after the decimal point is dropped. So the answer becomes 0. 0 times 100 will give us 0, and 100 minus 0 is going to give us what? 100. So we have to be very careful about some of these small things. To correct this error, what you do is you can either make this a float by adding 0.0 after 20 or after the 100. You pick your choice. I'll write 20.0. Then now we can run the program again. And sure enough, it gives us the correct selling price, that is 80. Don't worry about this part here so much, but basically you can see what it's doing is that it's telling us the selling price is %.2f, and we have the selling price here. What usually happens is that this %2f is acting as a placeholder whereby this selling price will be substituted. We'll understand more on this in the subsequent session, that is session 4. We are formatting this correct to 2 decimal places because most countries they go up to 2 decimal places when dealing with currencies. Let's move on and look at the precedence of operators. Precedence establishes the hierarchy or the order of one set of operators over another when an arithmetic expression is to be evaluated. It refers to the order in which C will evaluate those operators, and the precedence of the operators can be altered by enclosing the expression in parentheses. Parentheses is the normal brackets, depending on which English you're using. Let's look at the operators, the operator class, the operator, and the associativity. When we have the unary, that is either minus, plus plus, or minus minus, these ones, their associativity, that is in case you have multiple, you evaluate them starting from the right side moving to the left. For binary, we have this caret symbol. This is from left to right. So you start from the left side moving to the right. Then for the multiplicative, that is the times, divide, and modulus. If you have multiple, then you start from the left moving to the right. For binary plus or minus, that is the additive. Their associativity is from left to right. And the assignment, you remember we said this starts from the right moving to the left. Let's look at an example to help us understand this. We have this sum here, minus 8 times 4 modulus 2 minus 3. Let's do this together. If you look at all these operators, the one with the highest precedence is the unary minus. Basically, we are making 8 a negative number. Then after that, the times and the modulus, they have the same precedence. Hence, we use the rules of associativity. So we'll start with the multiplication, then we get the remainder. Negative 8 times 4 is going to give us, this will give us minus 32 modulus 2 minus 3. Then the modulus has a higher precedence than the minus. Therefore, we get the modulus. So minus 32 modulus 2, we get 0. Then minus 3. 0 minus 3 basically is going to give us negative 3. The result of this expression will be minus 3. The steps are given here exactly the way we have followed them, and you can see we finally wind up with a result of minus 3. The precedence between comparison operators, they're evaluated from left to right. That is greater than, less than, equal. Basically, those ones we start from the left moving to the right. Let's see what happens for the logical operators. The NOT operator has the highest precedence, followed by the AND, and finally the OR. And when you have multiple instances of this, their associativity is from right moving to the left. Let's look at an example to help us understand this. Consider the following expression. We have false or true and not false and true. Of course, we have seen not has the highest precedence. So this is where we are going to start, not false. This part evaluates to true. Then we have two ands. We have the and on this side and the one on this side. We have said the associativity for the logical operators is from the right moving to the left. This part gives us a true, so this is going to be true and true. This evaluates to true. And then we have another, this part evaluated to true. We have another true and true. This evaluates to true. Then finally we have the false or true, and this evaluates to true. If you don't remember this, kindly recap from your programming practices and techniques, session 5. Let's look at the general precedence rules among the operators. When an equation uses more than one type of operator, then the order of precedence has to be established with the different types of operators. We start with the arithmetic operators, then we move to the comparison and end up with the logical operators. Let's look at a simple example. We have 2 times 3 plus 4 divided by 2 greater than 3 and 3 less than 5 or 10 less than 9. Let's copy this and do it together in a notepad. We have multiplication, we have division. These basically have a higher precedence than anything else. But now, since these two are at the same level, we are going to evaluate them moving from the left going to the right. So we'll start by multiplying 2 times 3, and this is going to give us 6. Then we divide 4 by 2. This is going to give us 2. And we can write the result of that first. So 6 and 2 greater than 3 and 3 less than 5 or 10 less than 9. Now we do the addition. So this is going to be 8 greater than 3 and 3 less than 5 or 10 less than 9. When we have this, we do the comparison first, then we wind up with the logical operators. This part is going to evaluate to 8 is greater than 3, that is true. 3 less than 5, this is true. 10 less than 9, this part evaluates to false. So the result of this is going to be, this is true, true, false, and has a higher precedence than the OR. So this is going to be true and true or false. True and true is going to evaluate to true. So this is going to be true or false, and true or false basically evaluates to true. That is the result of our expression. The same steps we've taken, we can go through this very quickly. So we are going to start with the arithmetic operations. That is 2 times 3, then 4 divided by 2. This evaluates to 6 and this evaluates to 2. Then we do the addition, that is 8 greater than 3 and 3 less than 5 or 10 less than 9. We are left with true and true or false. So we start with and, it has a higher precedence than or. This evaluates to true, then true or false, and as we got, this gives us a true answer. Now, what about if you want to change the precedence? If you remember the previous example where we were calculating the discount, we wanted to start by doing the division 20 divided by 100. That is why we put it in brackets or parentheses. So parentheses has the highest level of precedence, and the precedence of operators can be modified using the brackets or parentheses. Operators of lower precedence with parentheses assume the highest precedence and they get executed first. In case you have nested parentheses or brackets, then the innermost parentheses or brackets get evaluated first. So we'll start with this. After we solve this, then we solve this. Then finally we get to the outermost set of parentheses or brackets. An expression consisting of many sets of parentheses gets processed from the left moving to the right. That is why in the earlier example, I'm talking about this. Here we had several sets of brackets. We evaluated this starting from the left moving towards the right. So this was what was guiding me in that particular slide. Let's look at an example here.
Consider the following example. We have 5 plus 9 times 3, 3 raised to power 2 minus 4, greater than 10, and 2 plus 2 raised to power 4 minus 8 divided by 4 greater than 6, or 2 less than 6 and 10 greater than 11. We have said we start with the innermost set of brackets.
This part is what we are going to evaluate first. Now remember, the comparison operators have a higher precedence than the logical operators. So we'll start with this side, then move to this side. 2 less than 6 evaluates to true. 10 greater than 11 evaluates to false. True and false, this is going to evaluate to false. We have 6 or false. Now once we get this, we get false as the result of this particular evaluation. Then we look at the next set of operations to be conducted. We have 2 plus 2 raised to power 4 minus 8 divided by 4. Now this has a higher precedence than this one. So we are going to raise 2 to power 4. This is 16. Then we divide 8 by 4. This is 2. Then the minus and the plus have the same precedence. This is going to be 2 plus 16. This gives us 18. 18 minus 2, this gives us 16. 16 greater than 6 evaluates to true. The result of this is going to be true or false, and the result of all is true. True or false evaluates to true. We'll see that in the subsequent slide. So this is where we are raising 2 raised to power 4 to give us 16. Do the division to give us 2. Do the addition, then the subtraction to give us 16. 16 greater than 6, this evaluates to true. So this is true or false, and true or false basically evaluates to true. We look at the remaining operations. We have 5 plus 9 times 3 raised to power 2 minus 4. We start by raising 3 to power 2. 3 to power 2 is 9. Then 9 times 9 will give us 81. Then plus and minus have the same precedence. This is going to be 5 plus 81 to give us 86. 86 minus 4 is going to give us 82. 82 greater than 10 is going to give us true. The other part we had a true, so true and true gives us true. I hope you have understood how we did that. Now please take some time, if you didn't understand, to rewind. You can go back a few steps and watch this so that it becomes very clear. These are the rules that your C compiler follows when it is conducting arithmetic, logical, and comparison operations, so that you can understand the kind of answer you're going to get. Now with that, we've come to the end of the session. Let's look at what it is we learned in this particular session. In this session, you learned about the assignment operators. You also learned how to work with the arithmetic operators in the C programming language. You are able to explain or we also learned about the relational and logical operators. We understood the bitwise logical operators and expression. We also looked at automatic type conversion and casts, and we wound up the session by looking at operator precedence. In the next session, we'll be covering the following. Session 4 basically covers input and output in C, and that is why we've not written any programs so far. Once we understand how to deal with input and output, then we can start writing our programs. By the end of this session, session 4, you'll be in a position to understand formatted input-output functions, that is scanf and printf, what you saw me using in that discount program. And you'll also learn how to use the character input-output functions, that is getChar and putChar or putChar. With that, we've come to the end of the session. See you in the next session. Nice time and God bless. Bye.